All right. Okay. So without further ado, so are you going to share your screen? You want to? Don't take your time. So Leonardo was asking here about refactoring legacy code without tests. It's really a big concern for me, right? So maybe. Good. So I think he's in the right place. All right. So now that we have Scott here, so let me just tell one thing, guys. Scott is an awesome. You know, Scott, me and Scott, we're good friends. I've been to his house several times. You know, I know his family, and this guy is an awesome person. You know, he's the one that's been writing the text for the Java 1 keynote, the community keynote for the last few years. He is an amazing person, and he especially has a very weird love, because he loves legacy code, right? So who does that? So with you guys, without further ado, my good friend is Scott, right?
Thank you, Bruno. I'll pay you later. So yes, my name is Scott Wiersham. I'm the founder of the Keep Calm and Refactor project. We'll discuss that later. So I'm going to start by saying hello, friends. Welcome to this presentation on adding tests to legacy code. Today I'll be your Bob Goff, and I'll show you that you can do this. I'll show you a few simple techniques that, as you apply them little by little over time, your code will become a work of art. All right, now, we all know the steps for doing TDD. When we write code, this is the process we're supposed to follow, right? What's the step we usually skip? That last one. And that's the most important one. I've been thinking a lot about that lately. So, you know, we're supposed to quickly write a test to test one simple thing. You run all your tests and you watch this new one fail. You make a small change to your code. You run all the tests and make it pass. That change that you make is supposed to be just enough to make the test pass. You watch that test pass, and then you refactor it to make it all better. So I work on an agile team with my job. We follow a Scrum method, and my other team members work for a different consulting company, and they are evaluated on their ability to deliver and maximize the number of dones they have at the end of the sprint. So everyone has this pressure to get my feature added or get my bug fixed and make sure that my tests pass and it's good enough, so let's move on as quickly as possible and get the dones. And that refactor thing, that can wait for another time. But that's exactly how you start to build a mess. That refactoring step is really an important step in maturity and teamwork. So you need to make sure that you take some time, you look at what you did, you see if there might be a better way. One thing you might try, I know this is interesting, you go ahead and you check in your working code, okay? So you know you've got something that works. And then you delete what you did, you start from scratch and you do it a different way. So you've got a completely different approach that you're taking from knowing how you got it to work already. So, you know, this refactoring step is where you consider how other people are going to be using the code, or you know, they're going to have to read it. Is it easy to understand? Do you need to rename something? Is there something you're duplicating you could turn into a function call? The bottom line is, do not skip this step here, okay? So that's our wonderful TDD process. But what about when you're supporting a legacy system? After all, that's what most of us do. So in my career, I've worked on, I think, 2 projects where we wrote something from scratch and they very quickly evolved into a mess. So let's look at the TDD process we use when we're debugging existing code rather than creating something new. So first, you add a test, and it may not be so quick because you've got to figure out how to wrap a test around this code that you're going to test. You have to find a way to break it out, and we'll discuss that later. So you then run that test and you watch the new one succeed. Why is that? Because what you're testing is the current specification, which is what the current application does. Even if it's a bug, that's what our specification is, because that's what it does. So you make a small change to the application code reflecting the fix that you want to make. Then you run all your tests again and you see your new one fail. If your new test doesn't fail, then you know that the test is wrong and you need to rewrite it. Okay, you go and you update your test to reflect the new change in the code. You run all the tests and you see everything pass. Then you go back and refactor that oh so important step. So now our reference for today is going to be the very excellent book Working Effectively with Legacy Code by Michael Feathers. It's a brilliant book. It's been out many years. If you don't have it, I strongly recommend it. You can see I've got my bookmark set that I'm constantly referring to situations and stuff. The one neat thing about it is that it's more like a recipe book for problems that you follow, problems that you find. And so, for instance, he'll start a chapter saying, "A dependency on libraries are killing me." So you go and if you have that problem, he's got the question there, you can answer it. I don't understand the code well enough to change it. Well, he shows you how to get around that problem. So I don't know, it's just, I'll go on and on about the book. I really like it. It's been very helpful in my career. One of the things he talks about is seams. Where is this chapter? Chapter 4, the seam model. He talks about seams. Now, a seam, he calls it a place where you can alter behavior in your program without editing in that place. So the way I look into it is, I look at it is that it's a way to insert a test or the ability to test this code without changing the functionality of the application, okay? So let me show you two quick ways to implement this technique of creating seams in the code. This method, which I learned from Llewellyn and Falco, it's called peel and slice. So imagine you have a method and some code at the top is untestable for some reason. I don't know, maybe it does a database access or does some UI or something like that. You want to be able to peel that off into a separate function, then put the rest of the method under test, okay? And that way you've made this testable. Now the slice is similar. You have some untestable code in the middle of the method. You want to be able to override the function there with a fake so that that allows you to control the state of the method with dummy data, and then you can make it testable. Okay, so let's look at some example code here. Okay, so you've got this this data access object, customer DAO, and it runs some vital functions. It loads the customer from the database, processes the result set, sets today's date, and it does some more processing. Okay, so you can see that this loading the customer from the database is going to be hard to test, and setting today's date is going to be hard to test consistently. So let's go ahead and create a seam. We'll peel the top part off, okay? We want to peel this load customer from the database function out. So what I do, I'll try and make this easy to follow here. So the function that we've got is run vital functions. So what I do is I create a secondary run vital functions method. Now before, what we did is you pass in the customer ID. Well, now I've got the version, the original version where you call the customer ID and you call load customer from database, and you get the result. And then the thing that we do is you process that result set the date, and you return the change ID, right? So what I'll do is take the rest of this code here and stick that into a method called process result set. And I'll create another function that I can go and I can pass in the expected result instead of loading it from the customer database. And my test function will create this fake test result that I can then pass into the process result set test, and I can test it in a consistent way. So, and then here's what's left of the original method: pass in the customer ID and the result set, which then does the processing and setting the date and more processing and all that. So you can see I have not changed the original functionality of the application at all. I've just added a seam whereby I can test this application now in a consistent way. All right, now let's look at the test call that we'd write for that. So I would create a new customer, test customer. I'd create a new test result object that looks like the result. It probably overrides the result methodology and functions, but it's going to be initialized with my test data. I'll create a new customer DAO, and I'll run for my test that I run the vital functions, which is that function that I that I replaced with a test version. I'll call run vital functions and pass in my test customer, and then I can assert that it equals what I expect it to equal. Pretty cool. And it's peeled. Now let's look at how to slice out this code that's in the middle. You know, we've got all this processing above. We got to set today's date. Well, that may be difficult to test. So what I'm going to do is I'm going to peel that out by I create a test customer DAO that extends the customer DAO, and it will override set today's date. Okay, and I will pass in the customer, and I'll have it do whatever processing it needs to, so that I won't be calling the original date. I'm really not concerned about testing whether or not the date function works. That's a library function. I'm going to assume that that works. What I'm going to do is override my call of that, so that my test runner here will again create my test customer, test result. I'll call my test customer DAO, and it will be using my my test to basically it'll call the set today's date function from my test, and it will go ahead and run the test, and I can see that it returns the result that I expect. So I've now peeled and sliced and made it all work. So it's pretty exciting. Now, another idea that Michael Feathers talks about is something called characterization tests. Now, if you have a class or a method and you need to make some change to it, but it doesn't have any tests, you want to make sure you don't break anything when you make your change. So for this, we use what's called a characterization test, which is you write a test that invokes a method and covers every path through the code. And that way you can be reasonably confident, you'll never be 100% sure, but reasonably confident that any changes you make aren't going to change the basic functionality of the method. You can refactor it with a lot more confidence. So for an excellent example of this, I will refer you to a set of videos by Emily Baki? She's the person who came up with the Gilded Rose kata. If you haven't heard of that yet, you're welcome. This is a really helpful thing that she put together that's basically some bad code that you go and refactor. So she shows how to use, how to put the Gilded Rose kata under characterization tests in using that kata. So additionally, a couple of years ago, I did a presentation at Oracle Code 1 where I introduced the approval tests library, and I showed people how to use that to quickly implement characterization tests on a set of code. So, those are two ways, two places where you can look to learn how to add characterization tests. If we've got some time at the end, I can show you quickly how I did that. Okay, now another really useful idea that I recently learned about is the concept of provable refactorings, which is from Arlo Belshi. These are things like renaming variables or extracting a method. Basically, the things that we did before, that they can be proven that they don't change the functionality of the code. And using these on otherwise untestable code will allow you to confidently refactor that code, make it more readable and maintainable. Okay, so for instance, when we did that peel, we replaced the function call with basically another call method, and we didn't change the functionality of the code. And so we were able to test it confidently, or even better, the slice that we did where we just overrode the functionality that worked. We didn't change any of the original functionality. So this link here is basically his effort to create a complete reference of provable refactorings. And it's similar to the canonical collection of design patterns in the Wikimedia. And the way he defines it, every recipe in here is guaranteed to be bug for bug compatible with whatever you did before you did this particular provable refactoring. So one thing to consider is that most of the refactorings that your IDE does are provable. If the IDE does it, it will more than likely be safe to do. You would do well to commit to muscle memory the keyboard shortcuts for the refactorings that you use the most. And here's the most common ones that you should use when you're refactoring code. That if you commit these to memory, you can say, okay, I need to rename this variable. Rather than use your mouse to go to the top and figure out what you need to do, just do a Shift F6 and you're right there. You've renamed it everywhere, and you're comfortable that you did it properly and safely. And you haven't lost your train of thought of what you're really trying to do. Same thing with if you're going to inline a variable or a function, Command-Alt-N for, well, that's in Mac, it would be Control-Alt-N in Windows or Linux. If you're going to extract a method, Control-Alt-M, or extract a variable from a set of code, Control-Alt-V. So if you're going to be doing refactoring of code, these things will help you to just do what you need to do and get on with what you're doing, and you don't lose your train of thought by committing this sort of thing to muscle memory. That's just sort of a free advice. Okay, so let's find a good example, right? Demos for this kind of thing are always hard because the examples we tend to show are usually like the one I had earlier, very contrived 3-line bits of code that don't really do anything useful, and they don't look anything like your code. So there's a few bits of example code that I use to show examples of how to do things. And this guy here, Wouter Lagerweis, I hope I didn't butcher his name too poorly. This guy put a pretty crazy piece of code. And I'll get into that a little bit later. But basically, he wrote a blog post where he showed how to refactor this code in 50 easy steps. And I noticed that he put the code up on GitHub, but it didn't even compile. So I had an overseas flight one time and couldn't sleep, so I went and created all the objects necessary, stub out whatever objects are necessary to get the code to compile, so I could start actually testing it and refactoring it confidently. So, but here, my friends, is my favorite ugly code base that I've found. This is an Android app for reading Reddit. And it's a reasonably popular application, and it's written almost completely by one person. So he is the 10x developer on that project. So let's say this is the code base that you have to work with. Here I can quickly show you what it looks like. So actually, we'll get to that. So if you've got to work with this code base, one cool thing about this is it's on GitHub. So you can use this tool called Code Climate. And it's a really helpful tool. You can run it against any set of code that's on GitHub for free. And so what we do is we run this code base against Code Climate, and we find the code that's been changed the most often and is the ugliest. So, I mean, if you just change ugly code anywhere, then you might break something that's worked fine for years and hasn't been touched for years. And frankly, if it ain't broke, you better have a good reason to go in there and fix it. But Code Climate goes through, and relatively quickly it does an analysis and shows you where things change a lot and where it's really a mess. So look here, it gives an estimate of how long it should take to make the recommended refactorings to fix this. So you click on the recommendation and it shows you specifically what you should change. So like here, it's got this, the cognitive complexity is too much, so you should refactor that, and it has 66 lines of code, so maybe you should break it up. And like I said, it should take about a week to go through and make the changes to this one method. Or to this one, yeah, that is a one class. So, and these are the things it recommends on this particular method. So now I will show you this code base, this particular class. Here, I will go and make that full screen. I'll scale up. So you can see, let's see, where was that? Line 247. So on activity results. So this is the method that it was suggesting was a little bit too long. And you can see it's got all kinds of if-else's, and it goes in really deep, and it has this if, and. And it's really hard to follow. So the amazing thing about this is this one class has 5,353 lines of code. And just looking at it, you can see it zigzags up and down all the way. And oh, this is one of my favorite things to see, commented out code. This is wonderful. One thing I'll suggest you, if you see commented out code, delete it. It's in the source code control. You can always get back to it if you need to. And that's a very big if, because you almost never need to go back and, oh yeah, there you go. That's my favorite part right there. Look how it's just completely off the screen. It's indented so much. Okay, so basically, in summary, you need to get working effectively with legacy code. This will save your save your life if you're having to work on legacy code. You need to understand the concept of seams. We've learned a little bit about how to peel and slice, and we've learned about characterization tests. So that's what I have to show you today. Again, I'm Scott Wiersham of the Keep Calm and Refactored project. You can meet me at keepcalmandrefactor.com. If you go into the whatever that other section is called, it's the Expo. I've got a book available, so you can. I've got an ebook available there. So if you register for my weekly message, then you can learn a little bit more about what I do and how I do it, and I'll send you a copy of the ebook that I wrote on the most effective refactorings and how to get your stuff done, how to find the low-hanging fruit. So does anybody have any questions? I can let me go ahead and I'll stop sharing for now. Does anybody have any questions, concerns, or anything? I can, if you like, if there's interest, I can show you my characterization test exercise, or this other code base that I was looking at before that might be helpful. See if anybody has any questions first. Another good book to read is Martin Fowler's Refactoring. This is sort of the one that started it all. Most of the, I would say all of the refactorings that your IDE currently supports are from this book. They basically went through to implement how he recommends to do the refactoring, and he's got a new version of this book out. This version of the refactoring book is for Java. He's got a new version of it out that is for JavaScript. I have not gotten that one yet. I need to. Okay. Well, I will go ahead, since I have a few more minutes, I'm going to go ahead and show you some of this code that I looked at and some of the things that I've done for it. This one by Werner, Joggerfeld, I guess is his name. Basically, this is the code that he had, and this is effectively unchanged. The only thing I had to do to get it to compile was a couple of typecasts that the language didn't support. But other than that, everything is exactly as he had it originally. Because I wanted to be able to take this code and refactor it to be to be more useful. But I wanted to be able to put a characterization test on it first. So you can see that it's got various constants and text hard-coded in there, and lots of big decimals here. You can see that this is code that isn't even used. And yeah, my favorite code that's commented out. That's always beautiful to see. If you go down here in the bottom, you'll see that there's a function that this one never gets called. And this one is only called by a function that's never called. So probably maybe a quarter of the code is never called. You can't get to it. And these are private functions. So I mean they can't be reached. So you can see that I ran my my code coverage. If you look over here on the left side, you see the green. See the green on there. So I'll show you the test that I have here. Let me go see if anybody has any question first. Yep. No questions yet. Okay, so what I did for my test is I decided that you can see over here, when you call the main function, you pass in, I don't know, 11 or 12 different parameters, and most of them are objects, or they're lists of objects. So it's a big old pile of stuff you're passing in there. So I said, okay, what I will do is I will go and I'll generate a list of records that look like this. So I went through, and for each member variable in the record, I go and generate a value, a unique value, and find all. I look through the code to see all the different combinations of values that are referenced in there. And so that's how I came up with this list. So basically, I've got a list of file upload command objects. I've got credit debit, which are in the constants file. And you got currencies, credit types. Turns out it's not used. It has fee records. So, and bank names, beneficiary names. So I went through and did all of that for each one of these, and I had to go and generate a letter. And what I have it do is go and I use the approval tests library. Now, very quickly, I'll show you the approval tests library. It's available from Maven. The Maven repository has it, or you can go to approvaltests.com and download it to add it to the project. And what I do, let me go and change something here so that we can get that. I'll change that. I will run this just so we can see a change. You know, basically the what it does is it goes through and it looks. You pass it a string and it goes through and it looks for any changes from the last time this was run. You can see that I just changed a 7 to an 8, and it goes and finds every change that's different. So see, there's all the combinations that I did. I got how many lines are in this test output. I got 8,000 lines of test output that it goes through, and any change that I make is now going to be reflected in here if it breaks. So the cool thing about this is that so if I go back, make that a 7 again, and I run my test, then you'll see that it passes because the file that I had saved before hasn't changed. So it just says, okay, your test passed. It works with IntelliJ, and it's a very handy tool that it will save you a lot of time in adding tests to your legacy code. You just write a test and you have it spit out something to a string. So I just basically have output is this string that just keeps getting appended to. I suppose probably would make it a little faster, making it the string collection or whatever that thing's called, but string buffer. And but regardless, it it makes testing legacy code not just adding tests, characterization test to legacy code, not just fun, which it actually kind of is, but also possible. Because in a lot of cases, can you imagine all the tests you would have to write to verify all of those values? That would be impossible to keep maintained. Whereas this, you just generate output, big old pile of output. You saw that only took, less than a second, and it worked great. Let's see here. How long did it take? It tells us 596 milliseconds. So it took about half a second. So that's pretty impressive. Now, one thing I just recently learned about is this idea of what's it called? Where'd it go? Boom. Right. Pit test. So this is oh gosh, where's my link to that? Mutation testing. Thank you. So mutation testing. Any questions here? No questions yet. So mutation testing is where this particular plugin to IntelliJ goes through and it makes changes to the bytecode as it runs it. So it will go and say, okay, this particular thing string utils, for instance, here, you got this, you replace the return value with a null, and it'll say, okay, do my tests fail now? Well, they do. So that means that this is properly tested. But here it goes through and it says, okay, what I'm going to do is I'm going to negate the conditional. So instead of is blank, it'll say is not blank. And it's going to check this particular value to see if that changes the test. And sure enough, it doesn't. So that means what I need to do is go into my test code and add an extra option to go and make sure that if I'm checking for a faulty account number record where the get sign is blank. Evidently, I don't have that. I thought I did. Faulty account number record. Fault temp records. What am I looking for again? Is the get sign, which is the credit debit. That's what the original code says. So we've got, and you can see I've got a blank in there. And so for some reason that's not working, I'll have to go through and debug the code to see why it's not getting to that for this particular test. But even inside it says, remove the call to set sign, and it still works. So that's interesting. So I'll have to go and see what that set sign does. Probably since that's part of my stub code, my stub doesn't really do much, so it probably isn't tested effectively. But so I don't care as much about that. So anyway, that's what I've been. This is sort of a project that I've been working on for a while to sort of create a characterization test. And this took a little time to put together, but you can see that I've taken this code that is, it's a big old pile of stuff that does a big old pile of things. And I've been able to, in, I don't know, I would say I've probably put in maybe 2-3 solid days of work in putting all this stuff together. But now, if I were to go and refactor it, I would be reasonably confident that I could make changes, and I can go through and with this mutation testing, I can go through and make even more sure that I'm refactoring it in a way that won't break the application. So that's pretty cool. Any other questions, concerns, or anything? Do I still have anybody in the room? Okay. Well, then let's see. I just have a few minutes left. I'm sorry for starting late, but that's the way it goes. So let me show you real quickly. I've got this. There's a test application. Basically, it's a training application that was put together by J.B. Rainsberger, and he's got it in various different languages. Since I worked mainly in Java, I went and got the Java version. So what this does is it's a game. So we've got this GameRunner, and it will go and run this game, and it generates output, and it shows who wins and that sort of thing. You can see that sports question answer was correct. Pat has 6 gold coins, so that's how it runs. So if I run it again, you see now Chet has 6 gold coins. Well, so basically, it's got a random value that's set here, and then it goes and runs the game based on this random value. So this is the ideal example of something where the peel operation would be really helpful. So I have very helpfully put together a test to make it easy to do this. So what I'll do is I'll create my other main method, which will look just like this main. Okay, and I will pass in the random. So what I can do here is take this code here, oops, well, what happened here? If I go from here, start a game, down here to the end, right? Take it and I put it in here, okay? And we'll pass in random, all this, and so that works, all right? And then the main we'll call other main, and we'll pass in brand. And you will see that it continues to work like it used to. Sue has 6 gold coins. Will it do it differently now? Chet has 6 gold coins, so that passes in random. So now I can go to my test and I can pass in, call other main, and I can pass in 0 as my my random seed. And then I can run this with code coverage and see that game was not included. Ah, right. So I need to go and include my coverage. GameRunner. Come on. Well, this is where you just don't know. Any questions, any concerns? Folks are dropping off. Basically, I need to add game.java to my code coverage here. And I forget how to do that. GameRunner. Yeah. And so if I want to do GameRunner tests, go here, test run, I want to run with coverage. There you go. Add. There we go. Much better. So now we've got code coverage here. Do this here. So now you can see what I've got as far as coverage. I'm covering all the code except for this right here is playable is never called. So, but otherwise I've got complete coverage by going through my test and calling it with a random seed. And I call my approval test, verify. You saw that the output is empty. Well, that's disappointing. So let's, what we can now do is go into GameRunner and find all the places where it goes, go to the game and find all the places where it does system out print line and replace those with a logging function call. And by doing that, oh, there's my timer. By doing that, we can go and make sure that we're doing our characterization test, and any refactoring that we do is going to be caught by the testing, and the approval test will go and report any problems to us. So, okay. Does anyone have any questions, concerns, interesting comments? Otherwise, what I can do is, let me see here. I can refresh the chat. Yeah. Nobody's asked any questions. So what I will do is I'll stick around for another minute or two. And if I don't hear from anybody, then I will just move on, because I want to see some of these other sessions as well. I really appreciate y'all coming. Again, if you go to the Expo, I've got an ebook available, so you can go check that out. And I'd love to hear from you. How's this conference been going for you? Have you seen this open tool before? I'm really impressed with it. I will say, I recommend that you go to the networking session. You can meet people there. It will randomly connect you with somebody, and you meet some really neat people that way. And between sessions, it's a great place to go. I'll tell you the story behind my my guitar playing Duke here. He is. Last year, I went to the Oracle Code 1 conference, and they had these big stickers of Duke flying in a rocket-powered surfboard, or playing a guitar, or riding a boat, or whatever else, and doing a motorcycle, or whatever things he was doing. And so at the end of the conference, all these posters were still up on the poles there. And I thought, what's going to happen is that the cleaning crew is going to come, and they're going to take those down and throw them away. I'd kind of like to take that home. So I went and found a trash can and pulled out the empty trash bag, and I peeled that very carefully off the wall and stuck it to the trash bag, and then rolled it up so I could take it home. And got it home, stuck it on a piece of masonite, and now I've got a nice background for when I do my presentations. Of course, I could have done a digital background, but this is cool too. And it's interesting, while we were doing that, a couple other folks saw that, and they decided to do the same thing. And the cleaning crew came up to us and said, we need to take a picture of you doing this, not because you're in trouble, but because the way the unions work, the union of people who are supposed to take those down is going to get upset with us for doing their work, because they can't get paid for it. We need to say, no, it wasn't us. It was this crazy computer geeks going around and defacing the property. So we're criminals stealing jobs from people in San Francisco. Sorry. Well. So it looks like we don't have any questions. Again, I appreciate you coming and attending, and I hope you have a great rest of the conference. And I will be around. You see the little envelope up in the upper left-hand corner there. You can, that's the upper right-hand corner there, and you can go and create, send me a message there, or you can connect with me. Otherwise, you saw my my information. I'm at Scott_Reaction, or Scott at keepcalmandrefactor.com. Again, with the Keep Calm and Refactor project. Y'all have a great day.